Hey everyone, it's John, and today we're going to continue back on the CCNP based switched video series. So if you recall from the previous video, we just discussed spanned VLANs. Now, as a quick recap, what actually is a spanned VLAN? Well, a spanned VLAN is a VLAN which appears on more than one switch in the network. So say for example, we had a marketing VLAN, and we had users attached to switch 5, and we also had users attached to switch 7. Straight away, because it appears on more than one switch, that VLAN is spanned across the network, okay? Now that does provide some things like more mobility in case of using a wireless VLAN. It allows free roaming and keeping the same IP address. But it isn't the best design, to be honest with you. It's suboptimal. And in this case, we're going to discuss local VLANs, which are seen as a kind of improvement on that design. So, what are local VLANs is the question. So, local VLANs are pretty much the opposite of a span VLAN. A local VLAN is when a VLAN is local to that switch. It does not span across the network. It only appears on one switch in the network. So say for example, if we look at this design I've got here, the local VLANs, a kind of common characteristic of a local VLAN is to have it defined by physical boundaries, okay? Because it's going to be defined by its existence to a physical switch. So in the case here, I'm designing my VLAN design scheme via floors. So switch 5 here is going to serve users on the first floor. Switch 6 is going to serve users on the second floor. Switch 7 on the third floor, and switch 8 on the 8th floor. So that means, let's look at switch 6, okay? We have got VLAN 20 attached to switch 6. Now you'll notice that VLAN 20, the green VLAN, will not appear attached to any other switch in the network, okay? So switch 5 will not have VLAN 20, switch 7, no VLAN 20, switch 8, no VLAN 20, okay? Now it's important to note, when I say a local VLAN, I don't mean that the switch only has one VLAN. The switch can have multiple VLANs, okay? So this is why I've added in multiple VLANs attached to switch 5 and switch 8, so there's no confusion there. The difference is that, like I say, there can be more than one VLAN on a switch, but that VLAN, whatever it is, can only be attached to one switch. Okay, does that make sense? So, say for example here, we've got this switch on the left here, switch 5. That's VLAN 10 we've got. This kind of winey red colour here, these are all VLAN 10. That's going to be floor 1's data VLAN. So if you're like a wired device, a normal PC, on the first floor, you'll be putting a VLAN 10 and it will attach to switch 5 and only switch 5, okay? None of the other switches will have VLAN 10 on it. Now, same again, like I said, with floor 1 will also have a voice VLAN, which is the purple VLAN here. This is VLAN 15. Now, switch 5 has more than one VLAN, but every VLAN which attaches to it only exists on that switch, and that's what a local VLAN actually is. So like I say, a common design scenario is to demarc things by physical location. So for example, floors in the network, or floors in the building rather, and typically you'll have a few VLANs to a single switch, so maybe 3 VLANs, okay? You might have floor 1 would have a data VLAN, so if you're on floor 1 and you've got a basic wired device, you would put in that VLAN. However, if you're on floor 1 and have an IP phone, you will also have another VLAN for that, okay? So that'll be, in this case, VLAN 15, so floor 1's voice goes into VLAN 15. So that'll be 2 VLANs on a single switch. And commonly you might see maybe a guest VLAN for that floor, or perhaps a wireless VLAN for that floor. But again, they will be localized to a single switch, and that's exactly what we're going to talk about in this video here, because when we do this, we actually get some quite efficient traffic paths and whatnot. So let's just discuss it then, okay? So if you recall from the previous video, what we had here was we had a layer 2 link here and a layer 2, and like I say, because we had VLAN spanning across the network, okay, that informed that decision to make this link here also layer 2, okay? So say for example, like if a VLAN wants to go, let's say these two are both in the same VLAN. They're obviously not because of colours, but let's just say for example they are. We would have the traffic path go here and then down here and then in here, okay? But again, what if this link failed? Because we've got layer 2 going across this link here, we could also take the path and have layer 2 this way, okay? So we're going to have this link as layer 2. Now, when you have local VLANs, we don't have this traffic path of VLANs going across the way. All VLANs do is they terminate at the actual switch they're attached to, okay? So VLAN 20 here will only go to this switch, so we don't need to worry about passing VLANs across the way. And because of that, what we can do is, well, just before I say that, okay, before I just say that, can we remember the consequence of what we did when we made this interconnect between distribution switches a layer 2? Well, what happened was this link here, sorry, bad drawing there, and this was layer 2. So what we did was we basically made a physical layer 2 loop, which meant the spanning tree would have to block a link. So in the case of this, maybe this link would be blocked and we couldn't shuttle traffic across this link. Now, because we have a local VLAN design this time and we don't have to have that east-west traffic flow so much, what we have here is we can convert this link here to layer 3 as well, just like all these layer 3 links, okay? Now what that does is immediately breaks the layer 2 loop here, because if we look at switch 5 for example now, okay? And we'll look at its layer 2 links. We've got a layer 2 link up here and it terminates now because we don't have layer 2 here anymore, and we've got layer 2 going up here and it terminates here as well. So no longer do we have this loop, okay, because actually the topology as layer 2 is just looking like this. It can't loop anymore, okay? So what that means is that both of the uplinks can now forward traffic, okay? Does that make sense? Okay, so when comparing it to the spanned VLAN, what we did in the case of the spanned VLAN, you can get a kind of form of pseudo load balancing by configuring your HSRP active router to be synchronized with your SDP root bridge. Now what that would effectively do would be this. That would cause SDP perhaps to block a link here, and for the traffic going across here, for the VLAN here, would also make this the active router for that VLAN. So we get some traffic going across here, and so that the other link wasn't completely blocked, we would have a per VLAN spanning tree instance to block this link here and also align the HSRP active router here, so we'd get some traffic here, okay? So in effect, we are, with span VLANs, we can still put traffic across here and put traffic across here, but here's the thing, right? The load balancing is per VLAN load balancing. Now what if your VLANs are, let's say you've got a marketing department and you've also got an HR department, okay? And let's say, for example, the market department use way more data than the HR department. So you might have this link is putting traffic forward for your marketing department, and this link is putting through traffic for your HR department. The reality is, this link can be completely overburdened. If one VLAN, set of VLAN, is using way more bandwidth than the other one, this is hardly getting used, this is really getting used. So we're not really getting much load balancing. So I mean, it's not really a great load balancing solution. It's better than having one link completely dead and everything going through here, of course. But again, it's per VLAN load balancing. It's not, you don't get quite the granular control as you would. Now here's the thing, see when we create local VLANs, and we make this link layer 2, sorry, layer 3, we convert it from layer 2, and we have these links, both of them, both redundant paths are now forwarding because there's no physical loop. What we can do is actually implement GLBP, Gateway Load Balancing Protocol. Now what that does is you can weight it such that some more traffic is across one link or the other, or you could round robin it just so it, or balance it, you know what I mean? So all traffic just goes 1, 2, 3, 4, 5, 6, 7, 8, and we get real load balancing. So straight away we get that. We also get a reduced blast domain when it comes to broadcast traffic. So if we've got, say, some broadcast issues in the purple VLAN here, it's going to be limited to really the links here. But imagine if we've got VLANs across all here, all of these links are going to be participating in that VLAN, so the broadcast is going to be streaming across the entire network. by keeping it localized to the switch, we don't have such problems. So effectively we get active redundant paths, we get higher availability, we get a reduced failure domain, and this is just a more scalable design, to be honest with you. Okay, doc. So what I want to do is also show you how that looks in the case of the physical design as I did with the last one. Okay, so just like the previous video on spanned VLANs, the scenario is very similar. Let's say we own a company called IPvZero Solutions, and we're looking at the London branch. This is the office building which the London branch owns. Okay, so we've got our topology here. Down the bottom here on the ground floor, we've got our, do you know what, I'll go to the graphic actually. So down on the ground floor, we have our distribution switches here, okay? And switch 3 is our access switch, which is going to serve users in floor 1. Switch 4 is going to serve users on the second floor. Switch 5 is going to serve users on the third floor. And switch 6 is going to serve users on the fourth floor. Now, like I said, because we're using a local VLAN design this time, we've actually made our VLAN design scheme around physical locations effectively. So you'll notice here the actual VLANs. VLAN 10 isn't a marketing VLAN or a sales VLAN, it's a floor 1 data VLAN. So if you're on the first floor and you are just sending regular data, so like a wired PC, you're going to go into this VLAN here, okay? Which is this one here. And if you're on the first floor again, but perhaps you've got voice data which needs to be prioritised, we need to do some quality of service on that, set it to expedited forwarding. We're going to put you in the purple VLAN, which is VLAN 15, which is again denoted by the physical location, floor 1, but it's voice this time, okay? But you'll notice that the purple VLAN, like I said, or this kind of winey red colour, they only appear on this floor. They effectively only go onto one access switch. We're not going to see it appear on this floor, or this floor, or this floor, okay? And the same is true for the rest of them. So VLAN 20 is the green one, and it's just going to be seen just on this floor here. It will only appear on this switch. And by the way, on the distribution switches, the distro switches will see all the VLANs. We should probably clarify that. But just on the access switches, they're only going to be local to one access switch. And again, so VLAN 30 is the third floor data. So if you're a data device on the third floor, you would put into this VLAN, which is this kind of turquoisey colour here. And it's this one here, again, only goes to switch 5 on this floor. And we've also got VLAN 40, which is if you are a basic PC on the fourth floor, you get put into VLAN 40, and that is a yellow VLAN. Serving users on the fourth floor, again terminated at this access switch here effectively. And VLAN 44 we've also created, for an example here, a wireless VLAN. So if you're wireless on floor 4, you'll go into this pink VLAN, which is this one here, and it ends here. So that would mean, let's say VLAN 44, we had the IP addressing scheme of 192.168.44.0/24. Okay, so we've got a user on here, and he is receiving a signal from this access point, okay? This is his phone or his laptop, whatever, and he's wandering right. Okay, as he's here, he's fine, okay? But see the thing, see once he gets out of range, let's say he goes down the stairs and he goes down to maybe the second floor, and let's just say we actually had another VLAN here, a floor 2 wireless, so we had a wee access point, which is another VLAN here. This, as he traversed a path down the stairs, unlike a span VLAN, he wouldn't keep his same IP address, because VLANs are localized. He would need to connect into this one and he would get a new address. He would no longer be on this subnet anymore, so that's one thing you need to be aware of. You get a bit less mobility with this design, but like I say, overall I do believe it's a far superior design than a span VLAN. And like I say, as I pointed out earlier, this interconnect between the distribution switches here is now a layer 3 link, which means that our layer 2 link here is here for switch 3, and it's both are forwarding, no block links. For switch 4, down here, it's a bit a bad line that, I'll clear that up a little bit and make it a little bit neater. So they're forwarding, and again forward in here, forward in here, and spanning tree is not blocking any of these links now. So we can basically, like I say, we can implement GLBP on these distro switches. So we've got both are active rather than active standby, and we can basically throw all our traffic down both these links from each floor, okay, and then start our routing out to the core and then wherever we go to our gateway or whatnot. So that's the generic kind of overview of a local VLAN. You get better availability, you get more scalability, you get a reduced blast radius when it comes to broadcast traffic, and it just is considered a better design. Now, I want to address a concern you might have, because you might be thinking, okay, well, let's say I've got a marketing department and I want to have them on different floors. How's this going to fall into line with this new design you're telling me, John? Well, here's the thing, okay? See the way Cisco teaches you VLANs, it will give you an idea of a marketing department and a sales department and an HR department, and they've all got their own little VLAN. The reality is that isn't really the best way to design your VLANs, and I'm going to cut back to the topology again and just put a little bit of context in this. So just hold a wee second and I'll pause the video. Okay, so let me address some concerns you might have about the idea of not having a VLAN for each department, because it's quite logical, I suppose. You would think that I've got a marketing department, they need to share resources, so I want to put them in the same VLAN so they can freely communicate and share resources with one another. But here's the thing, okay, see, resources nowadays, they tend to be centralized. Now, what do I mean when I say that? I mean that what you're typically going to have is something like this. My really good art skills. Okay, now these are servers. So you'd have a server VLAN, okay? And this would typically be running Active Directory. So if you're in a corporation, you sign on a PC, your username is going to denote which organizational unit you're into. So if you're in, say, a sales group, you will authenticate in to the server, and the server will basically grant you access to resources. So if you are a sales employee, it doesn't matter what floor you're on or what VLAN it is, you're going to be cutting in to the network all the way to hit the servers, so long as you can access the servers, and the server will dictate what access you get. So if you're on the same floor or a different floor, it doesn't matter. Salespeople will see the sales resources, marketing people will see the marketing resources, and if there is stuff that has to be shared throughout the company between all employees, there'll be a shared drive for all that, and that'll be covered by your central resources in the server room, effectively. And the other thing which tends to happen nowadays is a big thing is we have cloud, which means you're going to have internet access. So you might have an Office 365 email account. Again, doesn't matter what floor you're on, what VLAN it is, all you need is internet access. Okay, so your resources in terms of what your department needs will be controlled by servers and typically through cloud resources. The idea that you've got is maybe a salesperson here and need to talk to the same salesperson on the same VLAN to share resources is not really the way it goes. It's a good way to teach VLANs, of course, but in the real world you're not really going to see this. So like I say, a local VLAN design is pretty much a full improvement, I think, on a span VLAN. There's some caveats in which you can't do it. Like I say, if you really need mobility and stuff like that, maybe a span VLAN works for you, some wireless stuff, some guest stuff perhaps, maybe multicast and whatnot. But like I say, I do think this is definitely an improvement because of the high availability, the scalability, simplifying your spanning tree issue and whatnot. It's a lot better. So, like I say, one thing I want to really point out is when I'm talking about local VLANs though, I mean they are local to the access switch. So if we've got a VLAN here, all the VLANs need to be on the two distribution switches. We're going to have our interface VLANs for all the VLANs on these two, okay? So when I say local VLANs, I mean local to the access layer, and the distro will have all the VLANs which encompass all of these access layer switches. Okay, doc, so that's pretty much the end of this video here, talking about local VLANs. The next one we're going to talk about is the level up from this yet again. So we had span VLANs, local VLANs, and the next one is an even better design, I think, which is called layer 3 rooted access, where we move the rooted part of the network, all the links down to the access layer. And we'll discuss why I think that's the best design yet, and that'll be the next video. Okay, doke. So thanks very much for watching, and I'll see you guys soon. Bye bye.